Hello guys, welcome to today's class. In this class, we are going to discuss few more problems based on half-range Fourier series. Half-range Fourier series means either maybe we have to construct sine series and also cosine series. It's already written one of the problem on the board. Find the half-range sine series for the function f of x is x into pi minus x in the interval x greater than 0 less than pi, and hence deduce that 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube minus 1 by 7 cube etc. equals pi cube divided by 32. Now deduce part, you know how to do it in the general construction of Fourier series. Similar way we are going to do the deduce part. First we have to take a look in how to construct half range Fourier sine series for the function. What's the function they given? X into pi into pi minus x. Now solution. First you write what's the given in the problem. Given f of x equals x into pi minus x. For our convenient, instead of taking x outside, better I have to multiply it with each of the term. What we get? Pi into x minus x square over what's the interval? 0 comma pi. I told number of times in the my previous video of half range. When you're talking about half range sine series or cosine series, once you half range, instead of half range, they may will use simply sine series or cosine series. In that case, keep in mind immediately you have to take what is my general interval is 0 to n equal to the given interval. What's the given interval? 0 to pi. Now don't confuse with half range and general construction of Fourier series. Half range means always our interval is 0 to L, equal to the upper limit. L is equal to pi. L is equal to pi. That implies n pi x by L is nothing but n pi x by pi is cancelled. Finally we get nx. Now I have to write the what is the half range Fourier series. Half range sine series for f of x for the given function f of x over what's the interval 0 comma pi is f of x equals sine series means only is involving one summation a naught and a n is 0 1 to infinity bn sine of nx with respect to x, where what is my Bn formula is 2 by L 2 by pi 0 to pi f of x into sine nx with respect to x. Now I want to find out the Bn value. Now 2 by pi. First, without knowing Fourier quotient, we can't construct the series. Now 2 by pi 0 to pi. What is function? Given is pi x minus x square into sine nx, yeah, with respect to x. In the next step, now is a product of two functions. If you want to evaluate this integral, I go for which one? Actually, I go for UV rule or Bernoulli's rule. In the UV rule, first I have to decide which one is U function, which one is V function. Pi x minus x square is 0 after the few derivatives. After the second derivative, therefore treated this as u. Sine functions are v function because sine function is not equal to 0 up to till nth derivative. 2 by pi goes infinitely. The derivative of sine nx. Keep outside. From the uv rule, u function into integration of v function. What is integration of sine is minus cos of nx divided by quotient of x is n minus what is derivative of first term pi into derivative of x is 1 minus what is derivative of x square 2x into, again I have to integrate. While doing integration, keep the constant. What's the constant? Minus 1 by n is a constant. Keep it outside. Now, after that, yeah, keep it outside. Now, what we get? Minus 1 by n as itself. What is integration of cos sine nx? By again, we get another n, we get n square. Plus, what is derivative of pi is 0, minus 2 into derivative of x with respect to x is 1. And again, I have to integrate. What is integration of sign? Minus. You already have minus, we get minus into minus plus cos nx by n cube. Now, most of the students, they're doing mistake here. Once we get negative sign, they're going to write minus into minus plus. Don't write like that. Once you take this minus here, while doing here, integration of sign, what we get minus is wrong. Suppose you did small mistake taking sign, entire the value is wrong, the construction also is not correct. Finally, you are expecting out of that 1 mark, out of 7 or 6, 5 like that. Okay. Now, that's why must and should have to be careful. That's why I insist the student, what we get in the first integral, you please write it in the flower bracket. In the second integral, flower bracket. Now, as simplified, inside the flower bracket itself, we get minus sign. That's why. Whenever we get simplification is possible, you do it inside the flower bracket. Don't carry that negative sign with outside of the flower bracket. Okay. That is a very, very important. We are going to stop here. Why? Because observe here the constant is, what is the next higher derivative of the constant is 0. It's already discussed in the previous videos. Whenever we are going to use UV rule or Bernoulli's rule, in that case, once we get a derivative value is constant, that's the last term of the corresponding UV rule or Bernoulli's rule. In the next step, carefully we are going to apply the limits. I told this point also. I discussed in so many problem. Whenever having a product of sine or cos function, before going to apply the upper and lower limit term by term, first you verify what happened that trigonometric function corresponding the given limit. Cos of nx for x is equal to pi. Upper limit is pi. X is equal to pi means cos n pi. What is cos n pi value? Minus 1 to the power of n. X is equal to 0, cos 0. What is cos 0 is 1. This shows that cosine function is not equal to 0 for both upper and lower limit. Similarly, I have to verify sin nx for x is equal to pi. X is equal to pi means sin n pi. What is sin n pi value? You already know that. Sin n pi is, yeah, just a minute. To write clearly, x is equal to pi, yeah. Sin n pi. What is sin n pi value? Is 0. Again, I have to put x is equal to 0 for sin nx. What we get? Sin 0. What is sin 0? Is 0. This shows that both upper and lower limit sine function is 0. Whenever having the product of sine function, we have to write that this is 0 means product must be 0. In the next step, we are going to apply upper and lower limit. Those they have a term having cosine function. While applying upper and lower limit, keep the constant outside. Minus 1 by n. Apply the upper limit. What is my upper limit? Pi. Pi into pi square minus x is pi, we get pi square. Observe carefully, x is pi square. Here pi into pi square into cos n pi. What is cos n pi? Is minus 1 to the power of n. Minus x is 0. X is 0. What happened? This factor must be 0. Cos 0 is 1. Now in the next step, plus into minus is minus 2 by n cube of, apply the upper limit. What's the upper limit? Cos n pi minus 1 to the power of n minus cos 0 is 1. Observe carefully here. Pi square minus pi square is 0. The entire this term is 0 and also this also 0. The only remaining this term. While taking this term, what I'm going to do here, I'm taking negative sign inside the flower bracket. 2 into 2, 4. 4 by pi n cube of 1 minus of minus 1 to the power of n. This is my Bn. This is my Bn. Now here observe carefully. Once we get Bn, what we are going to do further? Now before moving to the next step, first I have to verify whether this Bn is true, means it's finite for n ranging from 1 to infinity. How can you know that? I told number of times, once you get n or bn, pick the denominator n factor. What is denominator n factor is n cube equal to 0. And then you find out the value of n. What we get? N is 0. N is 0, only we get denominator 0. Then whenever we get denominator 0, then only we are expecting the value of the Bn is infinity. But here n is 0. 0 is not included here because summation start from 1 to infinity. Therefore, what we are going to write? Confidently, I have to write this is true for n is equal to 1, 2, 3, etc. After this step, before moving to the construction of Fourier series, this point also explains so many problems. Whenever inside the flower bracket have one of the term is 1, another term is minus 1 to the power of n. Some even cases commonly 0 and odd cases maybe we get common value. Now carefully observe here, the one of the thing is 1 minus of minus 1 to the power of n. See, observe, give the n is 1 because n ranging from 1 to infinity means n may be even, n may be odd. Give odd value, say 1 minus of minus 2. Put n is equal to 3 minus 1 whole cube. What is minus 1 whole cube? Minus. Minus into minus plus 2. This shows that commonly we get 2 if n is odd. Okay. Suppose put even minus 1 whole square, 1 minus 1. Minus 1 to the power of 4, we get 1, 1 minus 1, 0 if n is even. Okay. Therefore, instead of writing the next step, we have to take in odd case, we get this flower bracket is 2. 4 2s are 8 divided by pi n cube if n is odd. If n is odd. Next is, now 0. This flower bracket is 0. What about the product must be 0 if n is even. Observe carefully, this flower bracket 0 means product must be 0. Therefore, this is Bn is 0 for n is equal to even, say 2, 4, 6, etc. The next, based on that, we are going to construct a Fourier series. F of x equals, yeah, while construction of Fourier series, keep the constant outside. What's a constant? And also while writing a summation, we have to take only a odd number because even cases are 0. 8 by pi is a constant. Summation, we are going to consider only odd case. Whenever we are consider only odd cases or even case, first we have to mention first two odd numbers. What are the first two odd numbers? 1 and 3. Suppose we are considering only even cases, we have to take first two even numbers. What are the first two numbers? 2, 4. Now once you write the first two odd numbers, say 1, 3, that means uh, actually only we consider odd values. Suppose we are writing simply n ranging from 1 to infinity means we are consider both even or odd. N is 1, 2, 3, 4 like that. Whenever you are taking only odd values, must and should have to mention first two odd values. Then that implies only we consider odd values. 1 by, similarly same thing for even case. 1 by n cube into sine nx. This is nothing but actually construction of what about Fourier series. Half range Fourier sine series is the required half range sine series of the given function over what's the interval 0 to. But not only I required only a construction of half range sine series, I want to deduce the result. Now first for our reference, I'm going to write in the right side corner what the result we are expecting in the problem. Reduced part is 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube minus 1 by 7 cube plus etc. must be equal to what? 5 cube by 32. And also this is a thing. Now I told number of times on my previous video, whenever I'm doing a deduce part, we don't have any particular method to deduce the result. Now only thing is, observe, you compare the what we construct the half range Fourier sine series to the required result. Based on that, I have to choose the suitable value of x. Once you choose the value of x, after that verify whether that value of x is belongs to the given limit. Then only we are going to put the corresponding value of x in the construction of what you constructed in the Fourier half range sine series. Suppose you expand the series, don't worry about the constant. Expand that, what we get, 1 by 1 cube sine x, and then put n is equal to 2 cube sine 2x, like that we get. But we don't want odd, even terms. We don't, it's fine 1 cube, 2 cube, like that. But in this result is not involving any what actually even terms. Only have 1 cube, 3 cube, 5 cube, 7 cube. We don't have any even. But here this expansion expand that we get in terms of both even or odd, and also involving sin x, sin 2x, sin 3x, sin 4x, like that. Now I want to convert. I don't want sin nx here, but the required only the odd terms, and also I required alternately plus and minus. Therefore, this shows that now we already know that anyway here involving sine function. Okay. Therefore, suppose I to choose, you know that what's the value of sine of n pi by 2. What is sine of n pi by 2 value? Is plus or minus 1 if n is odd. 0 if n is even. Yeah, observe carefully. I don't want even case. I want only odd case, but alternately I require what? Plus minus. Therefore, this value is suitable. Why I choose this? Because anyway I have a function sine. You know that sine of n pi by 2 only retain the odd numbers. We get plus or minus, and 0 even cases. So automatically eliminate even case. Therefore, what we are going to choose the value of x is pi by 2. But anyway, this pi by 2 is in the range 0 to pi. Therefore, no issue. Therefore, then we are going to take confidently the value of x is, put x is equal to pi by 2 in star. We get, this is a way to compare to choose the suitable value of x. Now what we get actually, f of pi by 2 is nothing but 8 by pi into, now I have to take summation, anyway have only odd value, no issue. Yeah, we don't have any even value, sine of n pi by 2. Yeah, now here I explain a little bit wrong here. Yeah, observe this, anyway you already have only odd values. Please observe carefully. Anyway, in the series you have odd values, okay? 1 by 3 cube. What's the next value of n is 3? 3 cube sine x. What's the next value of n is 5? Only odd value, 1 by 5 cube sine 5x, etc. Okay? This is a thing we get, but here I don't want sign, I want plus minus, but here we get only a positive sign. Suppose expand directly, and also involve sine 3x. Therefore, what I did, I choose sine of, put x is equal to pi by 2, sine of pi by 2 only is happening odd, but anyway summation also having odd, there is no issue. Even case is 0. Now 1, 2, 3, etc. Are clear? Why I have to choose x is equal to pi by 2? Because I want alternative plus minus. Directly we get 1 by cube, 1 by 3 cube. But I don't want sin x. Instead of sin x in the first term I required 1. In the second term, instead of sin 3x, I required minus 1. Therefore, which one is suitable? This one is suitable. X is equal to pi by 2. Once you put x is equal to pi by 2, now I have to find out what happened, what's my given function. Given function is f of x is equal to pi x into pi minus x. What is my f of pi by 2? Is nothing but pi by 2 into pi minus pi by 2. Pi minus pi by 2. Now pi minus pi by 2. Now here observe carefully if you want to write once again for this. This implies f of x, f of pi by 2 is nothing but what? Pi by 2 into pi minus pi by 2. Simplify that. Pi by 2 into pi by 2, what we get? Pi square by 4. This is f of pi by 2. After the simplification bracket also we get pi by 2, pi by 2 we get pi square by 4. Now I have to substitute the value of this pi square by 4. I take this as a cross multiplication, pi by 8 is nothing but expand this series 1 by 1 cube of sine n is equal to 1. N is equal to 1. What is sine pi by 2? 1. What x is equal to n is what about n is equal to 3? What we get? Sine of 3 pi by 2. What is sine of 3 pi by 2? Is minus 1. Minus 1 by 3 cube. Next put n is equal to 5. What is sine of 5 pi by 2? Is minus is plus. Sine of 5 pi by 2 is nothing but 1. Therefore we get this is nothing but plus 1 by 5 cube. So, sine of 7 pi by 2 is nothing but minus what we get 1 by 7 cube plus etc. You simplify that. Finally, we get pi cube by 32 is equal to 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube minus 1 by 7 cube plus etc. Now, automatically after the simplification, we get our required result of the deduced part. This is we are expecting that. Now, keep in mind here having 1 3. I did a small mistake here. Once you expand that, we get only odd term. Fine. We don't have any even term. Only we get odd term. You don't get it even. But in spite of all the terms, we get positive. But I required all alternative plus minus. Therefore, I'm going to choose the value of x is pi by 2. Once you choose x pi by 2, this become 1, this become minus, this become plus, next one is minus. Then automatically we get our required deduce part. This is a way to deduce the required result from the given function in the corresponding limit. After you construct either a Fourier series or maybe a French series. I'm going to do a little bit zoom out. Now I'm showing the entire problem in one screenshot. Yeah, observe this is the entire problem what I discussed now today. First problem, x into pi minus x. Now this is a way to do it. We are already familiar with how to apply UV rule and then how to deduce part in the construction of Fourier series. Therefore, now in half range is easy compared to construction because you are already familiar with all the steps. Now this is in one full screen. This is our what we discuss one problem. Okay. Now I move to the next problem. Yeah, yeah, it's okay. Now move to the next problem. Yeah, second problem. This problem actually obtained. Only I am discussing some important problem and also standard problems of range. Rest of the problems you please go through my course material. There I have solved so many problems. Cosine series, expansion of f of x equals x sin x. This is one of important problem. in 0 to pi, and hence deduce that 1 plus of 2 divided by 1 into 3 not 1.3. This is a similar type deduced part we already discussed where in Fourier construction of Fourier series. 1 into 3 minus 2 divided by 3 into 5 plus 2 divided by 5 into 7 minus etc. Okay, must be equal to 5 by 2. This is nothing but the problem. Obtain half-range Fourier cosine series expansion of f of x equal to x sin s over the interval 0, pi and deduce part. We already discussed in the previous one. Similarly, we are going to do the deduce part. First, we are going to construct the Fourier half-range Fourier cosine series, not sine series, cosine series. What's given here? Given is f of x is equal to x sin x. What's the interval? 0, pi. We are construct what actually? Half range Fourier cosine series. In both sine series and cosine series range in the interval what? 0 to L. Don't apply again once again even or odd. Keep in mind half range we already done everything. Half of that they asking. Don't take again half of that. There's no meaning. Okay, 0 to L, 0 to pi. From that immediately we get what's the value of L? L is pi. That implies n pi x by L is what? Pi pi cancel n x. Now I have to write half range cosine series for f of x over what's the interval? 0, pi is f of x equals a naught by 2 plus summation n ranging from 1 to infinity a n cos nx, where what is my a naught? 2 by L is 2 by pi, 0 to pi f of x dx. What is my an? 2 by pi, 0 to pi f of x into cos nx with respect to x. Now I have to find out one by one a naught and a n. Okay? Yeah. First we are going to find out a naught. A naught is 2 by pi, 0 to pi. What's a function? X sin x with respect to x. You go for which rule here? UV rule. While taking UV rule, because it's a product of two functions, this is my u function, this is my v function. Why? Because after the first derivative x is 0. Okay. Now here, here what we get actually 2 by pi x into what is integration of sine minus cos x by the quotient of x is 1 minus what is derivative of x is 1. Again integrate. While doing integration of cos, keep the minus sign outside. What is integration of cos? Sin x divided by quotient of x is 1 only. We are going to stop to evaluate the integral. Why? Because uh, here derivative value is constant. Now before moving to the next step, we have to verify cos and sin for both upper and lower limit. For cos x for x is equal to pi. For x is equal to pi, cos x is what? Cos pi. What is cos pi? Is minus 1. For x is equal to 0, cos 0 is 1. Okay, fine. Next move to sin x. For sin x, x is equal to pi. X is equal to pi sin pi. What is sin pi value? 0. Sin 0 is 0. Okay, fine. Move to the next step. 2 by pi half. Keep the negative sign outside. Apply the upper limit. Pi into cos pi. What is cos pi? Is minus 1. Minus x is 0. Cos 0 is 1. Minus this we already know that not necessary to apply the limit for this because just now we calculated sin x is upper and lower limit must be 0, therefore not necessary to write this step. Now I have to leave it as itself. Okay, this is 0. Minus into minus plus what about pi pi? See, observe 2 by pi. Suppose you confuse, you write it another step. Minus into minus plus, what we get? Pi. Now what we get? 2 a naught is 2. Similarly, I have to find out an. Yeah. An equals, yeah, we are finding an. An equals 2 by pi, 0 to pi, f of x is x into sin x, and then cos nx with respect to x. Okay. In the next step, now observe carefully here having a product of three functions. Product of how many functions? Three functions. X, sin x and cos nx. What we are going to do here, you take the product of these two functions, try to convert product of these two trigonometric function must be a sum or difference of two trigonometric functions by using transformation formula. You already know that this is similar to 2 sin A cos B. Sin and cos is there. What is 2 sin A? 2 sin A. Yeah, better I to move little bit this side because this otherwise the space is waste. No, that's why. Yeah, 2 sin A cos B. What is 2 sin A cos B? Sin of A plus B minus sin plus sin of A minus B plus sin of A minus B. 2 sin A cos B sin of A plus B plus sin of A minus B. What is A here? A is x. What is B here? Nx. Therefore, what we get A plus B is 1, x is common, 1 plus n into x. What is my A minus B is what actually? 1 minus n into x. Now from this, I take 2 inside. What we get? 2 sin x cos nx is nothing but 0 to pi x into, yeah, cos sin of A plus B. What is A plus B? Is 1 plus n into x. Okay. Plus sin of A minus B. What is A minus B? 1 minus n into x with respect to x. What we are going to do here, next step, you multiply by x with each term. Take integration of first term, integration of the second term. 1 by pi of using linear property. First you multiply by x. From the linear property, take integration of first term and integration of the second term. Plus 0 to pi x into sin of 1 minus n of x with respect to x. Okay, fine. In the next step, in each term is a product of two functions. Therefore, I go for which rule? UV rule or Bernoulli's rule. While taking UV rule, x is u function. The remaining as b because after the first derivative x is 0. Okay. Now here in the next step, okay, next step 1 by pi of from the UV rule x into integration of sin minus cos of 1 plus n into x divided by quotient of x. What is quotient of x is 1 plus n. Minus what is derivative of x is 1. Again I have to integrate cos. While doing integration of cos, I'll keep which one is constant? Minus. Minus of 1 by 1 plus n is constant. Integration of cos is sine of 1 plus n into x divided by, again we get 1 plus n whole square. Okay. Now once we get a constant, not necessary to move the further step because you already know that what is higher derivative constant must be 0 plus x into, again I move to the second term. What is integration of sin? Minus cos of 1 minus n into x divided by quotient of x is 1 minus n. Minus of, what is the differentiation of x is 1? Again I have to integrate. While doing integration, I'll keep minus of 1 minus n as constant. Integration of cos is sine of 1 minus n into x divided by, we get another 1 minus n because it's quotient of x whole square. Now I have to stop this also because here the derivative value is constant. Now close the square bracket also. Okay, carefully I have to do this. Before moving to the next step, we have to apply the value of upper and lower limit for the each and every term. First you verify what happened, trigonometry function sine and cos corresponding upper and lower limit. Therefore, now first I have to verify cos of 1 plus n into pi. Suppose you apply the upper limit for this, what we get? Cos of 1 plus n into pi. Similar type problem we already discussed wherein construction of Fourier series for x cos x. Cos of pi plus n pi. Cos of pi plus theta. What is cos of pi plus theta? Is minus cos theta. What is theta? N pi. Cos n pi is nothing but minus 1 to the power of n. This is the value of cos of 1 plus n into pi. Similarly, cos of, yeah, and also you know that cos 0. What is cos 0 is 1. Now I have to know this 1 minus n also. 1 minus n into pi. Again I have to simplify cos of pi minus theta. What is cos of pi minus theta is minus cos theta minus cos n pi. What we get? Minus of minus 1 to the power of n. Similarly, I have to find out based on sine. Upper limit. Sine of 1 plus n into pi is nothing but sine of pi plus theta. What is sine of pi plus theta is minus sine theta. What is theta here? N pi. What is sine n pi value is 0. Similarly, sine of 1 minus n into pi is nothing but sine of pi minus theta. What is sine of pi minus theta is nothing but sine theta. Sine theta. Theta is what? N pi. What is sine n pi value is 0. And also you know that sine 0 is nothing but 0. Now this shows that where you have sine, confidently write for upper limit and lower limit for sine of 1 plus n into pi is 0, sine of 1 minus n into x. Sine of 1 plus n x and sine of 1 minus x for pi and 0 is 0. Confidently write these two are 0. Only we are going to apply the limit for those terms having cosine functions. Now in the next step, this can also be written as 1 by pi of minus, while applying the upper and lower limit, keep the constant outside, minus of 1 by 1 plus n outside, apply the upper limit. What is my upper limit? Upper limit is actually x is pi, cos of 1 plus n into pi is minus of minus 1 to the power of n, minus lower limit, x is 0 but cos 0 is 1. Now move to this, plus into minus is minus. Keep minus 1 by 1 minus n outside. Apply the upper limit. What is my upper limit is pi. What we get actually x is pi. Cos of 1 minus n into pi is what? Minus of minus 1 to the power of n. Minus x is 0 but cos 0 is 1. Yeah. This is the easiest way to find out the value of the limit without doing a whatever very lengthy process. Once you know these values, then immediately we are neglecting some terms without applying the limits. Okay. In the next step, we have to simplify. Okay. In the next step, 1 by pi minus into minus plus pi into minus 1 to the power of n divided by 1 plus n minus into minus plus pi into minus 1 to the power of n divided by 1 minus n. Okay. In the next step, observe carefully here. In the next step, now I have to simplify further. What's the common factor? Pi into minus 1 to the power of n is common divided by pi. What's the remaining? 1 by 1 plus n plus 1 by 1 minus n. Take LCM for this. Now observe pi cancel here. Okay. Take LCM here. What we get LCM? Minus 1 to the power of n is 1 plus n into 1 minus n. 1 plus n. Sorry, this is 1 minus n. 1 minute. Yeah, once you take 1 minus n plus 1 plus n. What are the terms are cancelled here? Plus n and minus n are cancelled. 1 plus 1 is 2. Finally, we get an is nothing but what actually? 2 into minus 1 to the power of n divided by 1 plus n into 1 minus n. Now I think you clear how we get this step. Now once you observe carefully, now see, observe, this is my an. I think it's clear how we get these steps. Once we get an, I told number of times, you pick the denominator n factors. What are the two n factors are there? 1 plus n equal to 0, and also another one factor. What are the n factors? You pick it and equal to 0. One factor is involving n is 1 plus n, another factor is 1 minus n. 1 minus n equal to 0. From this, what happened here? This is nothing. This implies n is equal to minus 1. This implies n is equal to 1. But our summation for an start from n is equal to 1 to infinity. Therefore, we are neglecting this because the summation is not included, negative value neglected. But n is equal to 1 is included. Suppose n is equal to 1, what happened? The denominator is 0. Numerator is not equal to 0. What happened? A1 is what we n is equal to 1, we get infinity. For n is equal to 1, we get non-zero divided by 0, we get infinity. But that 1 is included in the summation. Therefore, what we are going to do here, we can't write a1 is infinity. What we are going to write here, an is true for n is greater than 1 or n greater than or equal to 2 or n is equal to 2, 3, etc. Means this meaning of this an is not defined for n is 1. Here we get n is equal to 1 infinity. We can't judge, we can't take a1 is infinity. What the meaning is, this an is not defined for n is equal to 1. It's not defined means you can't leave it. And to find out that value independently, separately, we already discussed in a previous video in one of the problem for x cos x. Which value is not defined? N is equal to 1. But n is equal to 1 is included in our summation. Therefore, we have to pick our an formula. This is my an formula, right? Now, for my reference, I choose this an, or better I have to take red. Now, this an is nothing but star. Okay. Now, I have to put n is equal to 1 on both sides in star. Yeah, because I want to find out a1. How to find out a1? Put n is equal to 1 in this an formula. Now, I have to find out that a1 independently or separately. Okay. In the next step, yeah. Put n is equal to 1 in star. That implies what actually a1, because I want to find out a1, that's why I have to put n is equal to 1. Suppose I have to find out 2, put n is equal to 2. Okay, 2 by pi, okay, 0 to pi, x sin x, n is equal to 1. Therefore, here we get cos x dx. 2 sin x cos x. What is 2 sin x cos x is sine to x, 0 to pi, x sine to x with respect to x. Fine. In the next step, we want to evaluate this integral using which rule? UV rule or Bernoulli's rule. Which one is U function? X. This is V function. Now what we get in the next step, once you apply UV rule, 1 by pi, x into what is integration of sine? Minus cos 2x divided by quotient of x is 2. Minus what is differentiation of x? 1. Again I have to integrate. What is integration of cos 2x? I have to keep minus of constant. Minus of what is integration of cos is sine 2x divided by 2 into 2 is 4. Okay. Now once we get derivative value is constant, that's the last term of the UV rule or Bernoulli's rule. Leave it as itself. Apply carefully upper and lower limit. Now while applying upper and lower limit, first you verify what happened. Sine 2x for x is equal to pi. For x is equal to pi, what we get? Sine 2 pi. What is sine 2 pi value? 0. For x is equal to 0, what is sine 0 is 0. And next, similarly, I have to verify cos. Cos 2x for x is equal to 0. X is equal to pi first. Cos 2 pi. What is cos 2 pi value? 1. X is equal to 0. What we get actually? Cos 0 is 1. Okay, fine. Now, apply carefully upper. This is we are writing confidently. This term must be 0. Not necessary to apply the upper and lower limit. Okay. In the next step, 1 by pi of keep minus of outside constant, apply the upper limit. What's upper limit? Pi into cos 2 pi. Cos 2 pi is 1 minus x is 0 but cos 0 is 1. Simplify that. 1 by pi minus of pi by 2. Pi pi cancel, what we get? Half. Minus half. A1 value, here we get minus half. Minus half. Yeah, see, observe here we get a from an value what we get actually infinity. From here what we get a1 is infinity. But we can't say that a1 is infinity. But keep in mind for 1 to infinity, either an or bn, we are expecting a finite value. For any value of n, we get infinite. Means we are writing is not defined. You find out that value of n value separately from the original formula for n or bn. Now this is a one of thing. Now here we get finite value, and then we have to construct the Fourier half-range Fourier cosine series. While constructing half-range Fourier cosine series, first you have to rewrite our series function. If of x is equal to what actually? A naught by 2. Yeah, don't take summation 1 to infinity because n is not defined for n is 1. I take that term separately. A1 cos x, and then you write the rest of the thing is together because our n is defined for 2, n is 2, 3, etc. Therefore 2 to infinity. An cos nx. Nx. Now I have to substitute Fourier series expansion, A naught Fourier quotients. What is A naught? You already know that. What is my A naught? A naught is 2. We already calculated A naught is actually 2. Now A naught is 2. A naught by 2 is what? 1 plus. Now what is my A1 value is minus half. Therefore plus into minus is minus. Therefore minus half of cos x. And then you have to write this. While writing this, I'll keep 2 as constant outside. Summation in ranging from 1 to infinity minus 1 to the power of n divided by 1 plus n into 1 minus n cos nx. This is my what about half range Fourier cosine series for the function x sin x over the interval. What's the interval? 0 to 5. Okay. It's the required half range cosine series for the given function. The given function over the interval 0 comma pi. They want deduce some result. Now for my reference I'm going to write what the result we are going to expecting in the problem. We are expecting the deduce part here is 1 plus of 2 by 1 into 3 minus 2 by 3 into 5 plus 2 by 5 into 7 minus etc. must be equal to pi by 2. This is they expecting in the deduce part. Now you compare this is my what we constructed Fourier series for x sin x. Now observe here in each of except first term, each of the case they having product of two values. If you want product of two values means 1 plus n into 1 minus n only. Now I don't want cos x. There is no cos x term. We have one. How we get one? Constant. Even though put any value of x, there is no effect this one value because one is a constant. Yeah, we can't, only we are replacing the value of x here. There is no change in 1. Therefore, this is as written. I don't want this. In each of the summation, outside the summation having 2, definitely we get what actually outside the summation having 2, then each of the terms, suppose expand this summation, we get this. If you want to expand this summation for our reference, just I'm expanding this summation. Which summation this? What we get? Put n is equal to 1. Put n is equal to 1, what we get? Minus 1 divided by 1 plus 1. No, sorry, this is not 1 to infinity, 2 to infinity, right? It's not 1 to infinity, but because you already taken n is equal to 1 separately, because this is not true for n is equal to 1. What's the first value of n? N is equal to 2. N is equal to 2. First you take n is 2 minus 1. What is 2 minus 1? 1 into 2 plus 1 is 3. Yeah. Now first you take the negative value, 1 minus lesser value. Next, what's the next value? 3. The next n values actually 3 I want. We have to observe carefully this. Now in the next step, see here 1 minus 2 we get negative value, right? See, observe carefully. Here I record 1 into 3, 3 into 5. What happened? Put n is equal to 2. 1 plus 2 is 3. 1 minus 2 is minus. Better I to rewrite this summation. Better before going to observe this, before going to take this, I'm going to take minus sign outside. What we get actually? Again I'm going to rewrite our summation because here 1 into 3. Here we get minus 1. Choice of you. Otherwise leave it as itself. Choice of you. Yeah. 1 minus 2. What is 1 minus 2 is minus 1. That's why I written minus into minus here itself we get plus. Choice of you. This is itself is, don't worry about that. N is equal to 2, we get this is plus, okay? Okay, fine. Once you put n is equal to 2, 1 plus 2 is 3, 1 minus 2 is minus 1. What we get actually here? Minus sign, okay? And next is actually put n is equal to 3. What is n is equal to 3? Minus 1 whole cube. We get minus, okay, by 1 divided by 1 minus 3. What is 1 minus 3? Is minus 2. Minus into minus, what we get? Plus 2. 2 into, see, 1, sorry, so what's the next value? Next value of this actually, n is equal to, yeah. In the next step, observe here we get, I'm expanding. N is equal to 2. Once you put n is equal to 2, this is correct. N is equal to 3. 1 plus 3 is 4. 1 minus 3 is minus 2. Okay. 1 into 2 into 4. What's the next value of third value of n? 2, 3, 4. 4 is what? Minus 1 whole raised power of 4 is plus. Okay. 1 divided by. Apply the what about the next value? 4. 1 plus 4 is 5. Okay, fine. And then 1 minus 4 is 3. We get minus 3. This is minus 3 into 5. Observe carefully. Once we expand this summation is involving 1.3, 1 into 3, 3 into 5, but extra what you have? 2.4. 2 into 4. I don't want even factors. Only I want product of two odd factors. 1 into 3, 3 into 5, 5 into 7. I want to eliminate 2 into 4. What is the next? 4 into 6. What's the next we have? 6 into 8. I don't want even product of two even factors in the series. I want to eliminate. If I want to eliminate what about the even series, observe carefully what happened my cos of n pi by 2. Just observe this point is a very very important cos of n pi by 2. What is cos of n pi by 2? Cos of n pi by 2 is 0 if n is odd. 0 if n is odd. Suppose even, see 0 if n is odd. Even means what? N is equal to 2. 2 into pi by 2, 2 to cancel cos pi minus 1. Put n is equal to 4. 4 by 2 is 2 pi cos 2 pi plus minus 1 if n is even. If n is even. I think it's clear this point we discussed already. Where we already discussed? We discussed already where in the second class of Fourier series. While explaining prerequisite, we explained this part. Okay. Now cos pi is minus 1, cos 2 pi plus 1, cos 3 pi minus 1. Therefore, 0 if n is odd, plus or minus 1 if n is even. Okay. Once you choose that, you feel how we get this. See, observe. Now only we are choosing even cases is not equal to 0. Odd cases are 0. Therefore, what we are going to take in the summation, n is equal to 2, 4, 6, 8, etc. n is equal to 2, you already know that this is a value. This is a value, okay? n is equal to, what about 4? n is equal to 4, what do you get? 5 and 3. Yeah. 1 by 1 by 1 into 3, 1 by 3 into 5 like that. Therefore, no issue. Please try to understand that. This is we get for odd case. N is equal to 3. N is equal to 2 is this, n is equal to 4 is equal to this. This is we are expecting our reduced part. Therefore, once you take x is equal to pi by 2, cos n pi by 2 is suitable because even cases are retained, odd case are 0. In this case, even case I want to retain, I don't want uh, odd value of n because once you put odd value of n, what we get? Once you put odd value, we get a even value. 2 into 4, 4 into 6, 6 into 8. I don't want that. I want 1 into 3, 3 into 5, 5 into 7, etc. Therefore, what's the value of x? We are going to take pi by 2 because cos n pi by 2 is written which value? N value. Don't confuse. Yeah, retain n value, how we get that? Observe. Once you put, because subtracting 1 and adding 1 for even value, definitely we get odd value. Subtracting odd and adding 1, subtract and add of 1 to odd value that tends to which value? Even value. Now 1 plus n, 1 minus n. For odd, what we get? Even. Yes? Even value, it turns to odd value. Okay? Now, what we are going to take here, put x is equal to, or before going to put that value, better I to take minus sign outside. 1 minus half of cos x. Once you put x is equal to pi by 2, cos pi by 2 is 0. Once you take minus sign outside, what we get? N ranging from 2 to infinity, minus 1 to the power of n. Instead of 1 minus 1, what we are going to write? N minus 1. We are taken which one outside? Minus sign. Now there is no this type of ambiguity here. Cos nx. I am treated, this is my double star. We already taken single star for an. Now I am going to take, this is my double star. Okay, fine. Now we are going to put what actually x is equal to pi by 2. Once you put x is equal to pi by 2, which one is retained? Even case. Once you put even value of n, subtract 1, add by 1 for even, that turns to which value? Odd. Once you put add or subtract for 1 to even value, that becomes what? Odd value. Therefore, put x is equal to pi by 2. And also pi by 2 is in the range 0 to pi. Therefore, x is equal to pi by 2 in double star. We get f of pi by 2 equals 1 minus cos pi by 2. What is cos pi by 2? 0. Automatically we get 0. Minus 2. Now, once you take cos n pi by 2, only which case are remaining? Even case. Therefore, I have to choose only even 2, 4, etc. to infinity. Minus 1 to the power of n divided by n minus 1 into n plus 1 into cos of n pi by 2. Now I think it's clear why I taken minus sign, because suppose here I have to keep the minus sign, 1 minus 2 we get minus sign. Better I have to write it 1 minus n is n minus 1 for our reference. Whenever add and subtract 1 to even number, that becomes odd. You already know that. You expand this. Now simultaneously I have to find out the value of what actually? F of pi by 2. What is f of x? X sin x. What is f of pi by 2? Pi by 2 into sin pi by 2. What is sin pi by 2 value? 1. We get pi by 2. Okay. Now this value is nothing but pi by 2 equals 1 minus of 2 into, apply the first value, minus 1 whole square. See, now observe minus 1 whole square. What is minus 1? Now 1 minus 1 whole square is 1 divided by 2 minus 1, 1 into 2 plus 1 is 3. 1 into 3 into put n is equal to 2. 2, 2 cancel cos pi. I'll write cos pi. After that I'm writing the value. Okay. Next put n is equal to 4. Put n is equal to 4. See, minus 1 to the power of n is 1 if n is even, right? Minus 1 if n is odd. Yeah. Now all are even, therefore we get plus 1 value only. 1 divided by 4 minus 1 is 3. 4 plus 1 is 5. Cos of 2 pi. Okay. And then plus 1 by 6. 6 minus 1, 5. 6 plus 1, 7. Cos of 6 pi by 2 means what actually? Cos of 3 pi plus etc. Okay. Simplify that. Pi by 2 equals 1 minus 2. What is cos pi? Minus 1 by 1 into 3. What is cos 2 pi? 1. 3 into 5. What is cos 3 pi? Minus 1 by 5 into 7. What's the next term actually? 1 by plus 1 by 7 into 9. What is 7 into 9 into what about cos 4? What 4 pi is plus. Here we get 1 by 7 into 9 minus etc. Okay. Now I have to multiply it by minus sign. I take it minus n inside the bracket. What we get? Pi by 2 equals I take minus sign inside because I want to deduce the result. 1 plus of the minus and become plus, plus become minus. This is I want. 5 into 7 minus etc. Observe carefully. This is we are expecting where in the required result. If you want, try to zoom out a little bit. Then we have to observe this. Yeah, this is I want to prove the result. Yeah, same result we get here. No, this is a one of important to deduce part. See, observe carefully. 1 minus n, suppose you subtract that, we get negative. What I did, I taken minus n outside, I converted n minus 1. Put first value of n. N is what actually 2. Once you put 2 minus 1 and then 2 plus 1. 1 into 3. Then what actually next n is equal to 3. I have to put, we get this like that. Okay. But I don't want 2 into 4, 4 into 6, 6 into 8. I want only odd factors. Therefore, now what we are going to take cos n pi by 2. Put x is equal to pi by 2. Once you put x is equal to pi by 2, we get only even cases are remaining plus or minus, odd cases is 0. I want retaining even case because you are adding plus 1 or minus 1 for even value that turns to odd number. That's why you are retaining even values. Okay, this is a way to deduce the required result carefully to give the value of x. Now if you want to simplify further, this is a thing. Some cases they're going to ask different way also. Yeah, r. I have to subtract minus 1 here, 1 in the right hand side. What we get, pi minus 1 equals 2 into 1 by 1 into 3 minus 3 into 5 plus 1 by 5 into 7 minus etc. Take LCM, 5 minus 2 by 2. Take 2 as a cross multiplication. What we get, pi minus 2 by 2. Take 2 as cross multiply, pi minus 2 by 4. Equal to 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7, etc. This is one of the problem. Observe carefully. Either they are going to ask this or this. Both are must be same only. I think it's clear how to do it, how to proceed, especially for this problem. You feel it's lengthy, but explained so many times. I take explained very slowly also. Why the aim is the student must be understand how to solve French Fourier cosine series for the function x into cos x in the interval. Yeah, we can't go far. It's very, suppose I go this very small, you are not able to see. What I'm going to do here, I'll show it half of that. Those are required for screenshot for this problem, better I to take screenshot for this problem. Yeah, I'll move to the first step. See, this is the second problem. They're going to, this is my problem. Yeah, observe carefully. Yeah, what I did, first I had to take the value of x 0 to n to 0 to pi, and then you have to write a naught en, and then carefully apply UV rule. In while finding n, first you apply transformation formula. I told this point, whenever you have to use transformation formula, before you applying UV rule or Bernoulli's rule, in such cases, usually we get 1 plus n or 1 minus n like that. Keep in mind, before going to apply UV rule or Bernoulli's rule, we are consider transformation formula to convert product of two trigonometric function must be sum or difference of the trigonometric function. There you must and should have to take care either an or bn, at least one of the value of 1 to infinity is not defined. Such value I have to find out independently. This is one of very important thing. I think it's clear for this point of view. Yeah, this is the first second problem. And then before moving to the next step, I find out carefully for each and every, even the simple thing I explained, carefully observe for this. Yeah, you move to the up to from this to this construction of what actually? French Fourier cosine series. Okay, I find out a1 because this already used transformation formula. If I told one of the value for one term is not defined, which value n is equal to 1. How can you know that? Take the denominator and factor equal to 0, solve that, you find out. I neglect minus 1 because our summation is not included minus value. Only start from 1 to infinity. That value I have to find out to put n is equal to 1 in a formula, and then we get a1. While construction of Fourier series, I'll take a first term separate a1 cos x, substitute that value. This is my uh, French Fourier cosine series. After that, for our convenient, what I did, I taken minus n outside. We get n minus 1. Then expand that. Now, here I want to retain only odd factors. I don't want even. Therefore, I'm going to take cos of n. Put x is equal to pi by 2. Even though cos of n pi by 2 is plus or minus 1 for even case, we are adding subtracting 1 for that even number that becomes odd number. Now, after the simplification, we get the required result. This is our deduced part. Okay, this completes the problem. Now, come and meet next class some more different type of problem, how to construct French Fourier sine and cosine series. Thank you very much for listening my talk. Thank you. Bye. See you and take care.